All right. This is the window sharing. Good. This should be right. All right. Let's just wait for this to load up. I don't know if I can see. Join the. So, can people hear me? Let's check. Yeah, mic's working. Okay. All right. So this is also working. Yeah. So today we are going to do the part two, and I think I stopped at lab 3 yesterday. So we're going to start from this securing communication within Istio. So this is basically yeah. So this is the third lab where we secure communication within Istio. So this would be things like MTLS, I guess. But let's see. I still feel the screen is a bit small. So this will take some time. Make this full screen. Yeah, this is better. So in today's lab, okay, I'll just share this academic link also. Mm, yes, this is the link that we will just. So in the previous stream, what happened is I started with this STO certification. So I can just show you that also. Okay, this for some reason doesn't capture the. It should be page today's. So yeah, so this is the certification link. So the previous lab we went through the Istio primer, and we started with the hands-on lab, and we took the three first sessions. So these first sessions are about installing Istio. Okay, how to install it, like using mesh cuttle, or you can just use Helm also, but usually people use mesh cuttle, but it's up to it's usually GitOps, and or if you'll use Helm. Then you go and you install the Istio ingress gateway. So the first lab only shows you Istio as just a gateway, not a service mesh. So you can use Istio as just as a gateway. So what will happen is, if you've heard of Ingress Nginx or Glue Edge gateway, that's something similar. You'll have this a gateway, and you can do stuff like routing and all. That's it. So this third one is then where we add services to the mesh. So Istio currently has a sidecar pattern, and there's also a newer one that is ambient mesh. So the sidecar pattern, you have to restart. First, you have to label the namespace in Kubernetes, and after labeling it, you can restart the deployment, and it will add a sidecar to it. So you will see in the pod section, you'll have two pods rather than one. Not the replica. In the pod section, you'll have two pods. If you do a describe on the pod spec, right, you'll see that there are two pods. One is the HTO init one is a init container also, and there is one sidecar envoy proxy and one application. So the init container, uh, it basically uses this thing called IP tables, Istio IP tables, and it will do some routing IP table rules that, so all the traffic goes to that envoy port or something like that, and like block traffic on certain ports or something like that. So it's a whole command that runs on each this. We can see it here also in this lab, hopefully. So yeah. So after all that, you add your services like the sample apps to your mesh basically, and then you will have a service mesh. So now this is securing communication. So let's see what we have first. Yes, we have this web API and all this running. And you'll notice that there are two. So let's see what it has. Correct. This is a bit irritating. Okay, describe here in action. Create describe HTML in action. Okay. So here, the thing that I was talking about before, you will notice that there is this init container that runs here. So init containers, if people who are watching don't know, init containers are basically something that runs before everything, before all other containers. It will init it, and it will do whatever it has to do and exit. So this is what the init container is. It runs the HTO IP tables rules, and it will add all these commands. You can also view this by just doing an exec into the container. There's a command somewhere. Let's save it. Yeah, this one, I think. Yeah, if you do this, you'll be able to see what these parameters are basically. So, and then we have the normal sidecar container and all that. So here you'll notice that first it's saying HTML when it was created, then it says web API and then proxy. Okay, so there is no set say order, but there is a way to force the order of the proxy container and web API. For example, if your web API wants to reach out to the internet or something, until the HTTP proxy hasn't started, you won't be able to connect. So there is a hold proxy, a hold application until proxy annotation or something that you can apply. That also I think is shown here. So okay, let's start this lab. So we are in the right directory. Yeah, so this lab is going to show you how to do MTLS as well as normal plain text traffic and secure connections between the services basically. So by default, Istio upgrades connection securely from the source service sidecar to the target side. This is why you saw the lock icon in Kiali. So, okay, so there we also have Kiali here. I think it's not up yet. So we don't have it at all. So there should be a Istio add-ons thing somewhere. I can't see clearly here. So it's called, I think, add-ons. Yeah, so yeah, so let's just apply this. Right. So there is a thing where you skip the workshops and half the things are not applied because it's supposed to go with the flow. So now we should be seeing Kiali and all. Yeah, so Kiali is here, and then we do okay, sometime we'll have to wait, I think. Kiali, okay, it's not yet running. Uh, so yeah, in the meanwhile, we'll just continue. So here it says by default, HTO upgrades the connection to make it secure from the source to the service sidecar proxy. Okay, so the source services sidecar proxy to the target. So two sidecars between two sidecars, it secures the connection automatically. Which is why it's probably okay when onboarding your services to your HTO service mesh to have communications. Around our plain text, if mutual TLS communication fails, you wouldn't want this in production environment. So currently, the peer authentication between two sidecars is permissive. Means in case TLS fails, traffic will still be allowed. So to enable strict TLS, first let's see if Kiali is come up. Okay, so Kiali is up. Now we should see this. Yeah. Okay. So now we can see all these nodes here. Yeah, so these are all the current nodes. So once you start sending traffic to this, you will see these lines that get connected, and you can sort of get a trace of like where the connections are going. We'll see that. So we'll do peer authentication. So now we have set the default mode of our traffic to strict. Okay. Now if we do get peer authentication, we should see this. Yeah. So it says strict. So it says because HTO system is a root namespace, this is the default for all the services in the mesh regarding which namespace. So it's like a global rule that we have set for communication. If you had set this in any other namespace, this would only be uh, probably global for that namespace. You can send some traffic. Okay, so we created sleep apps. Uh, so there was already sleep apps here. Okay, anyways, let's try to send traffic. Okay, so we are going to do Oh, sorry. So it's saying that it will fail because the web hyphen API service can only be accessed via MTLS. Okay, and the sleep pod in the default namespace doesn't have the sidecar proxy. Let's check that. We get pod. Okay, so currently there is no sidecar proxy for the sleep app. Okay, and so it doesn't have the needed keys and certificates to communicate via mutual TLS. Run the same command from the sleep pod in the Istio in action namespace. Okay, so I just have to change this. Istio in action. Yeah, so here you can see we are getting the response because the sleep pod has got a sidecar proxy. So sidecar to sidecar is already secure. Like when you install the sidecar, it automatically upgrades the connection because it has all the certs and all by default. So it can do MTLS by default. Now we'll see this in Kiali. And now they're just telling us to do the same thing. Uh okay, so to curl, and I will also make it silent. That did not work. Should be silent. Somewhere something is like that. Nothing is there. Weird, weird. Yeah. So we should now be seeing the traffic here. It is somewhere. Yes. Okay. So now we can see the traffic, and there is also this option where you can see traffic animation. Yes. So I don't know if it's visible, but let's zoom in. Right. So you can see this traffic going from wherever it's coming. For now, example, I'm doing it from the sleep app. Sleep app traffic is coming. No, I'm not doing it from the sleep app. I'm doing it from the terminal. So from the terminal, this is coming to the gateway. The gateway sending it inside the mesh, inside this namespace, right? Istio in action, and you can see that web API calls web API one recommendation one purchase history and purchase. So all these are going through. Uh, these are all the basic requests that are going through. There's also the security thing that I can yeah. Yes. So if you have MTLS, right, you'll see this lock icon in Kiali. If there's no MTLS, you won't see this lock, right? So yes, you should observe this with this traffic animation and security values. Okay, so now we'll be understanding how MTLS works in the Istio service mesh. So Istio has a very good Istio Cuttle tool or Istio CTL. So if you do things like now we are doing proxy config. So any proxy that Istio runs, like a Envoy proxy, whichever sidecar. So every sidecar is an Envoy proxy, right? So you can see you can see stuff of the proxy, whatever is happening. You can see it via the tools. So now we are doing Istio proxy config secret. So what does this do? Istio config Let's see. So you can just do PC also, that is also the same. It says it's under development. Retrieve the secret for a given pod from online. So we are seeing what secrets are loaded within the pod. So deploy that. So if we do this, we get cert chain, that is your certificate and private key probably, or no private key. I don't know if private key is required. And we have a root CA here. So why is there no private key? But okay, so we can do stuff. We can check who is the uh, issuer and all. So let's check the issuer of the public certificate. So issuer is cluster.local. So cluster.local is your DNS. The default DNS for Kubernetes is cluster.local, the domain basically. And you can also check the default secret is valid. So I think that would be the date. Yeah. So you notice this command gives you a lot of good information. One is the serial number. This is important. It has to be correct serial numbers for the root CA. So if that's different, then you know that the root CA is different, and there is not before and not after. So Istio certificate rotation is a bit tricky from what I know, what I've seen is that you need to restart like your sidecars every time to get the new cert. So that is one thing. We also have the status of the cert, the resource name, the status. So these are all good things to note. The next thing is we are seeing the identity of the client certificate is correct or not. Yes. So in HTO there is something called as SPIFFE. So SPIFFE is a identity mechanism that HTO uses. It's I don't know what it stands for, but it's like a workload identity ID. So if you go to the net and just have SPIFFE, you should see this website. So where it tells you what it does. So it says onward. So it's like an identity for each sidecar basically. It should see it. It should be different for each sidecar that you use. Probably we can check that also. Yeah, we can check for the recommendation probably. Right. So the SPIFFE here is cluster.local ns html action essay recommendation. Same thing goes for this. So it's a different selector altogether. There will be a way that they use to see here it's saying understand the SPIFFE format used by HTO. Okay, so let's do some reading. So where do these values come from? Check the HTO config map in the HTO system namespace. Okay. Yes. So you can see here we are defining this trust domain. So meaning this domain is trusted by HTO. And if you review the sample apps, the web API service account here. Right. Service account is created. So now they are saying that how does this sidecar proxy get the needed key and or certificates? So in the Istio proxy container for the web API, recall there are few volumes. Okay, let's see that. Mm, was it for for so here you can see there are a lot of volume mounts. So I can see volume, where are the mounts? Yes, this one I think, yeah. So there are a lot of, because there are few volumes. Okay, so Istio CA cert, that is where this one. Istio, no, this is Istio D. Istio CA cert also there will be something here. So either this is a spelling mistake here, bro. Istio CA cert is a mounted volume. I can see Istio data, Istio pod info, Istio token. There's only Istio D CA cert, but probably it's that only. Mounted volume is from the Istio CSR root config map with the Istio action namespace. Okay. During the startup, Istio agent, also called as pilot agent, creates a private key for the web API, then sends a certificate signing request. So Avinash will be happy with this. So it creates a certificate signing request for the Istio CA control plane. Okay. So basically, we have a root CA, right? And this will create a private key from the for the private key to create a CSR to send it to the control plane, and then it will sign it using the Istio token and the web API service account token. So multiple things it is going to use, uh, and then it sends the certificates received from the Istio CA along with the private key to the Envoy proxy via the STS API. Okay. So it also does certificate rotation. What happens is when the certificate expires, the Istio agent monitors the web API certificate, repeats the CSR request process described above, and periodically ensures each of the workload certificate is valid. So this is a bit tiny bit confusing because this is not matching here, but pretty sure it's this HTODCA certainly. Yeah, it's created from the HTOCA root cert. So it's the same config map. So the pilot agent that is there within this container, within the sidecar, it creates a private key and then sends a certificate signing request to the Istio CA. So this is going to the Istio control plane basically. We get Istio system. So it's most likely sending it to this. K logs for Istio system. So the default itself is pods. Okay. Okay, so now in here, let's pipe this to less. I don't know how much of this is visible to the stream because the screen size. This text is a bit small. If I zoom in, it becomes even worse. Okay, so these are all the things that happen in the startup and all. That's okay. What we want to see is okay. So see here it says HTOD certs are loaded. Added one cert to the trust domain. Okay, so this is done. A lot of things happening. Mostly some leader election and all that. So we want to actually filter for web API, right? Okay, so yes, see here it says sidecar injection request for web API. So this is probably when the pod started and the sidecar was injected. Then we can see that what can we see for this push request. Okay. So probably this is when it generated the cert and all. You see the XDS API is being used. So I think it pushed out a cert for it via these uh, listener discovery service, endpoint discovery service. So XDS is the Envoy XDS API. I don't know what ADS is. ADS probably something. I know EDS is endpoint, LDS is listener discovery service. Okay. Then anything front, anything happen? No. I think it doesn't show if the cert is generated or what. Doesn't have any error log messages for that. But we can see probably some command might be there to see that, but it's not showing up here. Anyways, let's go ahead. So now what we will do is yeah, so we now know how the cert is like it communicates via the sidecar, gets the cert from the pilot agent, and it puts it in the sidecar. So now we are going to see how MTLS is enforced. So when MTLS strict is enabled, you will find the Envoy proxy configuration for the Istio proxy container actually has a fewer lines. This is because what? This is because MTLS strict is enabled. You only allow traffic. Okay, so actually this has been a very big question that even I was asked when we were in Bangalore that for ambient, but same question like how would you if for example if I just launch a normal service, right? A normal Kubernetes service, and I wanted to just bypass the ambient proxy or the service, the ambient edgeborne network and all that proxy stuff. What would I like? How can I? How does this whole thing get enforced? So this is something similar to that question. So basically, uh, in sidecarless, I still have to go and check that. But for sidecar, it will only allow configurations that have MTLS. So if there's no MTLS, it won't just accept the traffic really. So don't need or want to filter chain to allow plain text. So if you want to allow, okay, one second. You already allow MTLS traffic and therefore don't need or want filter chain configurations to allow plain text to services in the mesh. Okay. So let's see the Envoy proxy config. So basically what that thing is saying is that when you're in permissive mode, there is something there's some filter chains that are enabled in Envoy. I don't have enough Envoy knowledge, but there is a filter chain in Envoy that every request passes through. So let's see. So it was telling us to look for, sure, transport protocol, transport protocol. Okay, so when in permissive mode, if you check this, now we are currently in strict TLS. So I don't think so we'll be able to see that. Hmm. So transport protocol raw buffer is still set here. What if we do it in permissive mode? So I think we have to wait for some time, then run this again. But I'm not seeing the difference. What is the difference? So we have TLS also, transport protocol TLS and raw buffer. But in raw buffer, I think it just allows all traffic, whether it is HTTPS or not HTTPS. Probably have to read about this transport protocol raw buffer. I have no idea on this at the moment. But yeah, you can always read later also for now. Transport protocol, no? If non-empty filter chain match, okay. Raw buffer default push with no transport feedback. Okay, so only TLS is allowed, I guess, in a sidecar, in strict mode basically. In non-strict mode, it won't do anything. Okay, so this is it. Um, okay, so the current configuration is not optimized for production environment by default because Istio listens to everything in your Kubernetes cluster. So all the routes and all are all created for everything by default. There is two things that you can use, that is export to and sidecar resource that you can use to trim the proxy. So the main important thing that people face, right, in a production environment later on, if they haven't uh, oh, Srinivasa is here. Okay. So the most I'd say uh, challenging problem when you have sidecar is the size of the configuration. So if you have not optimized it using sidecar resources or this export to thing, I haven't tried it out yet, but I have heard about this. Is what happens is after some time your configuration just keeps getting larger and larger if you don't optimize it. And then what happens is each proxy will have that configuration, right? And it will be like even 1 MB or 2 MB or 5 MB of configuration is a huge thing when you come into you know this proxy stuff, and every time the configuration is being pushed, so it's 5 MB just for one proxy. If you have 100, you'll have to push that much data every time, so it's a huge amount of data. That's why they have these options of the sidecar and export to sort of minimize the configuration. Now that lab is done, so we saw how to secure uh, and now we'll do control traffic. It's already started. So we will see how to control traffic between services in a Kubernetes environment. There's a simple uh, round robin load balancing. While Kubernetes does support rolling upgrades, this is fairly coarse grained and limited. You may find it necessary to use a dark launch. So there is something called as a canary testing. There's something called as a dark launch version of deployments. So I have only heard about the canary one, mostly canary, or I think blue green. Uh, so I think dark launch is something similar to blue green. So we are in the right folder. So this is how the dark launch diagram looks like. Basically, you will have a Istio and action namespace with all your services, and you will have purchase history V1 and V2. So phase 1 traffic only goes to purchase history 1. So let's try that. So you may find the V1 is rather boring as it always returns hello from purchase. So now we are trying to update this service, and it will take, I think, dynamic messages. So dark launch allows you to deploy and test new versions of a service while minimizing the impact. You can keep the new version of the service in the dark using a dark launch approach. Enables you to deliver new functions with reduced risk. So we'll see how this is done. So now we have this service, this deployment with the version 2. Okay, so yeah, this is a version 2 of this application. The main changes are v2 and everywhere wherever v2 and the newly added external service. So this is the external service URL which it will contact, I guess. So by default, if you deploy this, you'll have v1, v2, 50% will go to this uh, v1 and v2. So what we will do is we will use Istio's networking, and we will get control over what traffic is going basically. So the API gateway, if you recall, Kiali graph for your application. Then the purchase history is a schema of text. Uh, so we will be using something called the destination rule. Okay. In addition, we can also do subset based routing. So uh, we'll just see what is happening because this is too much to read at a time. Okay, so we will review the virtual service. So now currently we have a virtual service. The destination is this, right? Subset is v1. Currently this weight is 100. So all traffic will go to this. And then we have a destination rule with the host name only. Subset v1, label version v1, name v2, label version v2. Okay. So now there is no traffic that is going to v2. Okay. Let me just apply these two of this. One is a destination rule, one is a virtual service. So after you have configured Istio to send 100% to the v1, you can now deploy v2 of the purchase. Right. So dark launch is basically nothing is going to the v2. Okay. Usually if you had a normal deployment, Kubernetes would sort of do a 50-50 distribution to your application. But now it is not doing it, and it's for the same URL. If you notice, the URL is the same. So if it had a same endpoint, by default it would have a 50-50% traffic distribution. But now with Istio, since it's passing through Istio, I can control uh, where the traffic goes to basically. So if you notice, all is coming from purchase history v1 only because I have set the weight to 100 here. If you notice here, the weight is set to 100. If this was like 50 or something like that, then all the traffic hitting this would only go to would only go v1 v2 v1 v2. So that's also, then also there is this subset thing, and this subset is defined here, I guess. with the labels and the versions. That's cool. But we want to now verify V2. So recall purchase history and requires ability to. So we have a external URL that is in the pod, right? So I was talking about that thing before, right? Where if the pod requires internet connection, and Istio proxy starts later on, it won't be able to connect because all the traffic is going through Istio proxy, right? I mean to the Envoy proxy that is there. So now if you notice here, you will see that it failed because there was no internet connection. The proxy wasn't up, right? So no internet connection. This is in a way a bit secure also, because in case there is some URL that is bad or anything, it will just fail. But currently we need it to work, right? So we are going to do is we're going to use this hold application until proxy starts annotation, I think. See, right, so here you have this annotation, and it will just hold the application. So basically if you do this, when the application is starting, right, the proxy is starting, it will start before the application, so you will have internet access. So let's deploy this. It says deployed. Right now we are able to access the URL. So it's just an annotation that sort of sets the order of this. And now we can test from its own sidecar proxy. So we're just going to hit its own address. So every time you hit this, you get a different dynamic body basically. So now we are in the dark launch phase 2, where we will traffic goes to the purchase history based on the header value. Okay. So we're going to use a header based routing basically. So V1 traffic will still be there, and for V2 traffic, we will be moving it to the second function that we launched, but we will only do it for this user Tom. Right, so we are doing a virtual service, right, and we are going to do a HTTP match. Here we are having an HTTP match, and we can route. Cool. So we have this, and we are going to apply it. So this traffic is still 100%. Okay, so we are now going to route it, but we have done a header match here. So if we match this, it will go to this destination rather than hitting this. Mhm. Let's send some traffic now. Right, so this is the normal purchase history V1. Now we will do the header based. So we'll send a header with the user Tom. Yeah, and now we see we got that different response. So developers also can test if they put like a header developer or something like that. You can get a different response. Okay, so next is canary testing. Canary is good. Canary is what I think most of the people use. Things like Instagram, and also I think they use the same canary kind of deployment, because I have two accounts and one account sometimes gets a whole different set of features and the other account is still behind. So, or it could be based on the username also. So canary test I used to perform. So canary testing is more of a real time, like users will be testing it for you sort of scenario. So the way nowadays, people monitor, I would say, changes is they deploy the apps, right? And then they use the metrics to see the failure rates. So if there's a lot of failure rates, then they can what do you say, they can do a rollback. Argo CD also has this feature where you can, I think, specify the uh, metrics via Prometheus or something like that. For deployment, I think it is. I'm not sure if that is for like normal monitoring also. But if the metrics are like greater than or less than something, it will just do a rollback. But I'm not sure if it is like it does for after the sync is complete. I'm not sure about it. Okay. So we will do right. We have now we have distributed the traffic. It's 80/20. So notice here 80/20 for V2 and for V1 it is 80. So we have now applied this. We will generate some load on the web API service to check how many requests are served. So 80, 20. So out of 20, I think I know it's 20%. Yeah. So if you'll notice, more of it is V1, less of it is V2. So definitely you can see that there's a difference. Like it's not like round robin, like 1 2 1 2 1 2. It's more of a distribution. I think you can also visualize in Kiali. Yes. What is that line? Okay, I think it is showing me the request of that external URL also. So you notice here you can see the traffic distribution, how it is. So not all requests should go to V1. So it'll be like 2 requests to V1 or 3 4 requests to V1. What is changed? Okay, so let me just try to do this once again. Okay, it looks good. Yeah, I have no idea why it's not showing now. Yeah, it's showing now. This is how it's how the traffic is passing basically. And from here it goes outside of the cluster. It's pretty cool, yeah. Okay, so now we have all right. Now we will shift 50% of the traffic. So now we are all happy with the 80/20 stuff, and we will now do 50/50. So now if there were like 10 requests, I should see 5/5, and there is 20, then 10/10. Okay, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Mm, it's 11. 1, 2. Okay, so not exactly 50-50, but okay. Little error margin is okay. Roughly, I say roughly 50-50. So now in this graph, you should see it going, one by one, like one to V2, one to V2, V1, V2, both. That's good. Okay, so now we will shift all the traffic to V2. Right, so now there is no V1 at all. So it's all shifted to only V. And it should show up here also. I don't know why this graph keeps doing this. But yeah, if you notice now here, it's only going to V1. I mean V2. Nothing is going to V1. When you're using, so now let's see controlling outbound traffic. When you use Kubernetes, any application pod can make calls to services that are outside. So we can also restrict that. What if you want more control? Layer 7. Okay. So we'll try to restrict it basically, I think, on layer 7. What traffic was outside. So in production, you would really want just to keep certain external URLs. So even if the app goes rogue, it only. So it says by default anything is allowed and should be empty. So allow any is used. Now we'll update the Istio installation so that the registered external services are allowed. So let's try. So we have to do it only basically by on when we start. Basically when we install Istio. So I think it also works for an existing installation. Yeah, so if I do an Istio CTL install again, it just fully updates, I think, stuff. Doesn't restart anything. That's good. So it's basically just Helm in the back. Confirm the new output. So let's see now what it is. It's a registry only. See, now we are seeing error processing. So all outbound is blocked. So it can be inside the cluster also or outside the cluster also. Anything outbound. Oh no, no, sorry. Wait. It's only because of the purchase history. Because purchase history wants to connect to JSON placeholder typecode.com service. So let's check the pod logs. I can see X attempt envoy 3 to retries and the service can't connect to the external service. Okay. So the registered external services are allowed. So to fix this, we have to use something called as a service entry. Create the following service entry resource for JSON. So let's see what service entry does. So we have service entry, we have a name for it, we have the host, and its location is mesh external. Okay, the port number. So we can define what port and where only where it has to go, as well as the protocol and resolution. That's good. So we will apply. And now we will again send the and this. Okay. So now we have internet access. Hey, hey. Another important benefit is importing external services to serve is that you can use Istio routing rules with external services to define retries, timeout, and fault injection. So you can do what happens is you get like a router, and you can do things like, so similar to how virtual services in Istio, you get something similar to that. So now using virtual service, I can do things like timeout and all this on this host. Now this host is not in the cluster, but because of this service entry thing, I can now do things with the virtual service also. So if I do, and I do a timeout of 3 seconds. Sorry. So that's good. So basically I can do a 3 second timeout. And if I go in the service entry and probably remove this, it will just time out of 3 seconds. So that's good. So I can do things like retry and all this stuff on the virtual service because HTO has access to the host, right? That's going out. So it's also a good thing. So for example, it won't be only limited to for example, if it won't be limited to one route, I can do this globally. So like if I want now I have like a service that is very flaky. We keep losing internet connection with it. Then I can use this to change that. That's good. Do you want to securely restrict which bots can access a given external service? Should you send traffic? Okay, so I'm done. I will do the next lab Monday, I guess. Uh, what is the last thing? So if you want to visualize, head over to the Kiali lab. Where is my curve? So you should see that now V1 and V2 of purchase history are shown as its own workloads. Okay, yeah, it's a own separate workload V1, V2. That's cool. And now this is inside the app, the Istio action namespace. So that's good. So now we have like we know what where the traffic is going. That's good. So yeah, this is all. This is it for today's stream. Thank you. Okay. I don't know who's there, but
Okay, bye bye.